In the heart of Warsaw, within the Russian partition Poland, a child named Maria Skłodowska was born on November 7th, 1867. Her parents, both educators, instilled in her a profound love for knowledge from a very young age. Tragedy struck early, with her mother's death from tuberculosis, when Maria was only 10. Despite her grief, she excelled in her studies, graduating from her secondary school with top honors. Higher education for women was barred in Poland, a frustrating reality for a mind as brilliant as hers. She and her sister, Bronisława, made a pact to support each other's education abroad. Maria worked for several years as a governess, sending her earnings to her sister in Paris. During this time, she secretly attended the Flying University, a clandestine educational enterprise. Finally, in 1891, it was her turn to pursue her dreams in the vibrant city of Paris. She enrolled at the Sorbonne, immersing herself in the world of physics, chemistry, and mathematics. Life was difficult. She survived on bread, butter, and tea, often fainting from hunger. Her passion for science, however, burned brighter than any hardship. In 1894, she was seeking a laboratory space to conduct research on the magnetic properties of steel. A colleague introduced her to a quiet, brilliant scientist named Marie Curie. Pierre was the head of the laboratory at the School of Industrial Physics and Chemistry. He was immediately captivated by her intelligence and singular focus. Their shared love for science blossomed into a deep personal connection. Married in a simple civil ceremony in 1895, with Marie wearing a dark blue dress instead of a bridal gown. This same dress would serve as her laboratory uniform for many years. In 1896, Henri Becquerel discovered that uranium salts emitted a mysterious, penetrating ray. These Becquerel rays could pass through solid matter, a phenomenon that fascinated the scientific community. Marie Curie, searching for a doctoral thesis topic, was intrigued by this new form of radiation. She decided to conduct a systematic investigation into these mysterious uranium rays. Pierre, recognizing the importance of her work, set aside his own research on crystals to join her. They were granted the use of a damp, drafty shed at the school to serve as their laboratory. It was a former dissecting room, ill-suited for the delicate measurements they needed to perform. Marie's first step was to measure the electrical conductivity of the air exposed to uranium rays. She discovered that the intensity of the radiation was proportional to the amount of uranium present. This led her to a groundbreaking hypothesis. The radiation was an atomic property. She then began to test other known elements for similar properties. She found that thorium also emitted these rays, coining the term radioactivity. Her most startling discovery came when she examined a uranium ore called pitch blende. The pitch blende was far more radioactive than could be explained by its uranium content alone. She correctly inferred that the ore must contain a new, undiscovered element. This new element had to be incredibly radioactive to have such a powerful effect. The Curies now faced a monumental task: to isolate this unknown substance. They obtained tons of pitchblende waste from a mining factory in Bohemia. The work was physically grueling and intellectually demanding. They had to process the ore in massive batches to extract a minuscule amount of the new element. Marie took on the chemical separations, a task akin to being a factory worker. She would carry heavy containers and stir boiling liquids for hours on end. Pierre focused on the physical measurements, analyzing the properties of each separated fraction. The shed was freezing in the winter and suffocatingly hot in the summer. Noxious fumes from the chemical treatments filled the air they breathed. Despite the appalling conditions, Marie later called this period the happiest of her life. In July 1898, they successfully identified one of the new elements. They named it polonium in honor of Marie's beloved homeland, Poland Dotykai. But their work was not done. Another, even more powerful element remained. This second element was chemically different and much harder to isolate. In December 1898, they announced the discovery of the second element. They called it radium, from the Latin word radius, meaning ray. They had discovered radium, but they had not yet seen it. To prove its existence as a new element, they needed to isolate it in its pure form. This required several more years of relentless, back-breaking labor. They processed several tons of pitchblende to obtain just 1/10 of a gram of pure radium chloride. Finally, in 1902, Marie succeeded in preparing the first sample of pure radium. The substance had remarkable properties, unlike anything seen before. It continuously emitted heat and light, seemingly defying the laws of conservation of energy. One of the most magical properties of radium was its faint, ethereal glow. The Curies would often return to their shed at night just to see it. Marie described them as looking like faint, fairy lights. This glow was the visible evidence of the immense energy locked within the atom. In 1903, Marie became the first woman in France to be awarded a doctorate. Later that year, the Nobel Prize in Physics was announced for the discovery of radioactivity. Initially, the prize committee intended to honor only Becquerel and Marie Curie. Pierre, outraged at the omission of his wife, insisted that she share the honor. His protest was successful, and the prize was awarded jointly to the Curies and Becquerel. Marie Curie thus became the first woman to ever win a Nobel Prize. The prize brought them fame, but it also disrupted their cherished scientific privacy. They chose not to patent the radium isolation process, wanting it to benefit humanity. The Curies were often in poor health, unknowingly suffering from the effects of radiation exposure. Tragedy struck again in April 1906, when Pierre was killed in a street accident. Marie was devastated, left alone with two young daughters, Irene and Eve. Despite her profound grief, she resolved to continue the work they had started together. Sorbonne offered her Pierre's professorship, a position no woman had ever held. On her first day as professor, she began her lecture at the exact point where Pierre had left off. In 1911, her groundbreaking work was recognized with a second Nobel Prize, this time in chemistry. This award was for her isolation of pure radium and the study of its properties. She became the first person ever to win 2 Nobel Prizes in different scientific fields. When World War I broke out, Marie saw a new way for her discoveries to serve humanity. She knew that X-rays could help locate shrapnel in wounded soldiers. However, most hospitals at the front lines lacked X-ray equipment. Marie devised a plan to create mobile radiography units. These became known as Petites Curies, or Little Curies. She, along with her teenage daughter Irene, trained women to operate the equipment. Marie herself drove one of the vehicles to the front lines. Her work was instrumental in treating countless wounded soldiers. She fearlessly exposed herself to dangerous levels of radiation to save others. After the war, she continued her research at the Radium Institute in Paris. She became a global ambassador for science, raising funds for research. Years of handling radioactive materials had taken a severe toll on her health. She suffered from aplastic anemia, a blood disease caused by radiation exposure. Marie Curie died on July 4, 1934, a martyr to the science she helped create. Her notebooks are still so radioactive that they must be stored in lead-lined boxes. Her legacy transformed our understanding of the physical world and ushered in the atomic age. Her work laid the foundation for nuclear physics and for cancer therapy using radiation. She remains an enduring icon of scientific dedication, perseverance, and discovery. The young girl from Warsaw who dreamed of science had forever changed the world. Her early life was a constant struggle against financial hardship and societal barriers. She would often study in libraries until they closed, seeking warmth and knowledge. Meeting with Pierre was a turning point, a union of two brilliant scientific minds. Their first child, Irene, was born in 1897, adding a new dimension to their busy lives. The decision to study pitchblende was a gamble, based on a hunch and precise measurements. The shed was their kingdom, a place of intense labor and profound discovery. Each step of the chemical separation was a painstaking process of elimination. They were often exhausted, their bodies aching from the physical strain. The discovery of polonium was a huge victory, validating their hypothesis. Radium, however, was the true treasure, 1,000 times more active than uranium. The scientific world was initially skeptical, demanding irrefutable proof. The isolation of pure radium chloride in 1902 silenced all the doubters. The glowing tubes of radium became a public sensation and a scientific marvel. Doctors immediately began to explore the medical applications of this powerful new element. The Nobel Prize money allowed them to hire their first paid laboratory assistant. Pierre's sudden death was a blow not just to Marie, but to the entire world of science. Marie's decision to take his professorship was a courageous act of defiance against convention. She established the Radium Institute as a world-class center for chemistry and physics. The second Nobel Prize was a moment of personal vindication amidst public scandal. The Marie Curies saved an estimated 1 million soldiers' lives during the war. She donated her Nobel Prize medals to be melted down for the war effort, though they were not used. Her daughter Irene followed in her footsteps, becoming a brilliant scientist in her own right. Irene and her husband would later win their own Nobel Prize for discovering artificial radioactivity. Marie's trip to America in 1921 was a triumph, where she was gifted a gram of radium. The radium was a gift from the women of America, a symbol of solidarity. She saw the potential for both great good and great harm in her discovery. Her later years were dedicated to establishing research standards and promoting international cooperation. The burns on her hands were a constant, painful reminder of her long years of work. She never admitted that her illness was caused by her work, a final act of devotion. In 1995, her and Pierre's remains were moved to the Panthéon in Paris. She was the first woman to be honored there on her own merits. Her life story continues to inspire millions around the globe. The element curium, discovered in 1944, was named in honor of her and Pierre. She broke down barriers in science and society with quiet determination. The world was forever changed by the woman who glowed in the dark. Her scientific curiosity was a relentless force, driving her through poverty and loss. Pierre's invention, the electrometer, was the key that unlocked the first measurements. She meticulously documented every single measurement and chemical process. The air in the shed crackled with invisible energy, a silent danger they did not understand. They would transport the glowing tubes of radium in Pierre's waistcoat pocket. The discovery of radium challenged the 19th century belief that the atom was indivisible and stable. Marie's health began to noticeably decline after the birth of her second daughter in 1904. After Pierre's death, she poured her energy into creating a world-class laboratory as his monument. She faced xenophobic attacks from the French press during her career. Her work during the war required immense courage and logistical genius. The little Curies were often operated just kilometers from the front-line trenches. She personally trained over 150 women as radiological operators. Radium Institute in Paris became a hub for nuclear physicists from around the world. She believed deeply in science as a tool for peace and progress. Her final journey was to a sanatorium in the French Alps, seeking a cure that didn't exist. The cause of death was recorded, but the link to radium was not officially made at the time. Her research opened a Pandora's box of atomic energy, with all its potential and peril. The name Curie became synonymous with radioactivity and scientific revolution. She proved that a dedicated individual could overcome immense obstacles to reveal the universe's secrets.